So today we're going to continue with some vocabulary, and we're going to be measuring and constructing segment. Our vocabulary for today is coordinate, distance, length, construction, between, congruent segments, midpoint, bisect, and segment bisector. Our first postulate is 1-2-1, the ruler postulate. The points on a line can be put into a one-to-one correspondence with real numbers. That means that every line has one length. The distance between any 2 points is the absolute value of the difference of the coordinates. If the coordinates of point A and B are little a and little b, then the distance between A and B is A minus B, or B minus A. The distance between A and B is also called the length of segment AB, or AB. When we talk about a distance, you want to write the two letters just like you would if you were naming the segment, but you do not put the line over the top. So you can call it the length of line AB, like it says there, or you can just call it AB, which is the same thing. So when we look at our segment here down at the bottom, or our line down here at the bottom, we have segment AB marked off, and AB is equal to the absolute value of A minus B, or the absolute value of B minus A. Congruent segments are segments that have the same length. In this diagram, PQ is equal to RS, and remember there's no line above the PQ and RS because we're talking about distances. So the length of PQ is equal to the length of RS, so you can write line PQ is congruent, and that equal sign with the swoosh over it is congruent to RS, line RS. This is read, segment PQ is congruent to segment RS. We use tick marks to show congruent segments. So we put a little dash on each line to show that they're the same. Usually if you have a picture with more than one set of congruent lines, you would use 2 tick marks for the second pair, 3 tick marks for the third pair. Or if you want to do it like I do, you can use colored pencils or colored pens, and you can make each pair a different color. You can make a sketch or measure and draw segments. These may not be exact. A construction is a way of creating a figure that is more precise. One way to make a geometric construction is to use a compass and a straight edge, which is what we'll be learning for the rest of the year here. So to construct a segment congruent to line MN, segment MN, we're going to construct and compare using a compass and straight edge to construct ST congruent to MN. So go ahead and take a ruler, make a line MN. It does not matter how long your line is, but you want to make sure that the endpoints are M and N. Go ahead and measure it with a ruler, and then go ahead and draw a line underneath that you think is about the same size using your ruler. That's an approximation. It's not perfect, but it's pretty good. Then you can use a compass. If you start with line ST, you put the point of your compass at S and use your pencil to mark an arc at point T. Then you draw a new line, and you'll mark your first point and put the point of your compass on it, and then mark the distance with an arc and make that your second point. If you measure them, it shows that they are exactly the same length. So if we want to construct a segment congruent to JK, we go ahead and we take a line JK and we use our compass to measure how long it is. We put the point at J, make an arc at K, and then we draw a line with point S. We put our compass point at S and mark the arc on the line and label it T. Don't worry if you're not following along with these constructions exactly. We'll go over them in class on the whiteboard. In order for you to say that point A or point B is between 2 points A and C, all 3 points must lie on the same line, and AB plus BC needs to equal to AC, which is postulate 1-2-2, the segment addition postulate. Make sure you have this one written down especially because you will be using this a lot throughout your proofs. This is one of the most commonly used postulates. It says if B is between A and C, then AB AB plus BC is equal to AC, which makes sense because if we take half the line and add the other half of the line, it equals the whole line. The midpoint, M of AB, is the point that bisects or divides the segment in two congruent segments. If M is the midpoint of AB, then the distance from A to M is equal to the distance from M to B. So if AB is equal to 6, then AM is equal to 3 and MB is equal to 3.